In this screencast, we are going to go over solving systems of equations by the elimination method. So looking in our note packet at problem 1, it says Jeanette is trying to find the intersection point of these two equations. So first thing we're going to do, when you have these equations which are set up in standard form, which means that x and y are together on the equal sign, is we're going to see if we can try to add them together. When we add them together, our 3y's are going to eliminate, which is exactly what we wanted to happen. We're going to add up the x's, so 5x and 2x make 7x. Bring down our equal sign, and negative 2 plus 16 will give us 14. So we can now divide both sides by 7 to get x equals 2. Similar to what we did with the point of intersection with graphing and with substitution, we're going to have two parts to our answer. We're going to have an x and a y. So we know our x is 2, so I'm going to plug that back into my ordered pair. But now I need to solve for y. And you can pick any of these two equations to plug your 2 back in to find y. I'm going to just pick the top equation. So I'm going to have 3y plus 2, now instead of times x, times 2 equals negative 2. And we are going to solve. So we get 3y plus 4 equals negative 2. We'll have to subtract the 4 from both sides. And I've run out of space, so I'm just going to bring it up over here. So we have 3y now equals negative 6, and we'll divide both sides by 3. So we'll get y equals negative 2. So our ordered pair is going to be 2, negative 2. And just like the other two types of solving systems of equations, you can check to make sure this is right by plugging it back in. Moving on to number 2, Annie was going to use the elimination method, but when she tried to add them together, she noticed a problem. So if you take a look, and if you try to add these up, nothing is going to eliminate. So we have a couple of options. What we could do is we could subtract all 3 parts. Now, when you do it this way, you have to make sure you subtract everything. So our x's are going to eliminate. 7y minus a positive 3y is 4y. And then 13 minus 5 will give us 8. And then we can divide both sides by 4 to get y equals 2. The other way that you could think about this is multiplying one of these, it doesn't matter which one of these equations here, by a negative 1, and then adding them together. You would get the same result. So we know that our y value is 2. So we're going to plug this back into one of our equations. I'm just going to pick the top one. So we have 2x plus 7 times y, which is now 2, equals 13. So we get 2x plus 14 equals 13. And we'll subtract 14 on both sides. And again, I've run out of space. So we're going to have 2x now equals negative 1. And we'll divide both sides by 2. So x is going to give us negative 1/2, or you could say negative 0.5. And do not panic that it's wrong because it's a fraction. If you plug it back in, it will work out. So if we can't add them together, we can subtract them together. Moving on to problem 3, again, first thing you want to do is you want to see, okay, if I can take these and add them up, if anything eliminates, and you notice nothing will. The second thing is to see if you can subtract, and again, nothing is going to subtract. So at this point, you want to see what would be easiest to get rid of. Would it be easier to get rid of the x's or the y's? So you want to try to figure out, okay, what could I multiply my equation by, maybe the second equation, so that one of these x's or y's eliminates. So looking at this problem, I'm going to suggest that we get rid of the y value. So what we're going to do is we're going to multiply the whole bottom equation by 2. The top equation will stay exactly the same, but now the bottom equation becomes 6x minus 4y equals negative 30. So basically, we're taking the bottom equation and we're doubling it. Now when we add them together, our y's will eliminate. We can bring our x's down. So we get 13x equals negative 13. And then we can solve for x to get negative 1. So again, we know that that is the first number in our ordered pair. We're going to go back and plug it in to find our y value. And again, you can pick either equation. It does not matter. I'm going to plug it back into the top equation. So I'm going to take 7 times my negative 1 now, since that's x, plus 4y equals 17. So we get negative 7 plus 4y equals 17. Add 7 to both sides. So it leaves us with 4y equals 24. And then we can solve for y to get y is 6. So our ordered pair is going to be negative 1, comma 6. And again, you can go back and you can check that to make sure it's correct. This last question is probably the most difficult. And if you take a look, there's nothing that you can add or subtract them. But again, we want to focus on getting rid of x or y. So you could do a couple things. If you want to get rid of x, we could multiply this bottom equation by a negative 3. Or if we want to get rid of our y value, we would multiply the bottom equation by a 10. So you have 2 options. Since I find that people make mistakes when we multiply by negatives, I'm just going to keep it with a nice 10, and then that way we can add things together so the top equation stays exactly the same. The bottom equation, all 3 parts get multiplied by 10, so we have 20x plus 10y now equals 170. And now when we add them together, our y's are gone. We have our 26x now equals our 2, nope, that's not right, equals 182. And then we can divide both sides by 26. When we do that, we'll get x is equal to 7. So again, we know the first number in our ordered pair. We're now going to go back and plug it in. I'm going to plug it into the bottom equation this time. So I'm going to take 2 times x, or 2 times 7, plus y equals 17. So that gives me 14 plus y equals 17. So I'll subtract 14 from both sides to get y equals 3. So solving systems by elimination is very similar to substitution and graphing. You're finding the POI. And we will practice this more tomorrow. But please make sure you're taking the notes